So now let's look at the profiling module. So what is profiling? Profiling consists of running a program and then figuring out exactly where time is spent. So do you spend the time in this loop or in that loop? How many times do you execute this loop? What function is called from this function call, and things like this. So basically it helps you get a better understanding of how your program performs at runtime so that you can improve some particular parts, the ones you actually need to improve the overall performance of the program. So let's see a quick example. So first I've created a module, and the module I called it squares.py. And the module has a few functions, 3 actually, and the 3 functions give you 3 different ways of creating lists of squares. So the first one is using add. So I start with an empty list, and each time I want the list of squares up to n or n minus 1 squared. So the way I do it with add is that I start with an empty list, and for every index in my range, I will add to the end this little list with one element. So you can see that this will take a lot of overhead because I am creating these lists and then creating a new object and then changing the binding of temp to this new object. Okay, a slightly better way is with append. So append starts also with an empty list, but for every element in the index, I will add simply this I squared at the end. So there's some gain there because I don't have to copy the object and rebind. And finally, the last way is with list comprehensions. So this is relying the most on Python internals, but basically Python can figure out from the start that it will have to create a list of this length, and then it can start assigning I squared to it. So it has to do less manipulations in memory. So we expect the last one to be faster than the middle one, which is itself faster than the first. But let's see this in practice. So for this, I have 2 different ways of using the profiling module, and this will be timing lists.py and timing lists2.py. So in the first one, I have some basic code. So from squares, I'll import the 3 different ways of creating the list of squares, and then basically 200 times I will create a list according to each of those methods. And okay, so that's my code, and it does nothing else basically. But when I run this code with this specific command line, and it will be easy to adapt to your particular case, then it runs, and it doesn't just run it, it will tell me at the end how the program actually performed and who called what and when and how many times. So this is important. This is taking a bit longer, so let's pause the video. And there we go. So you see, this is the output of the profiling run, and you can see which function was called. So we called from squares.py on the first line, on the 10th line, on the 16th line. So you can see that this corresponds to this function, and the module itself. And you see how long it took per call. So 3,000th of a second, 1,000th of a second, 171,000th of a second, and the cumulative time for the 200 different function calls. So if you look back, indeed, everything was called 200 times. And you can see the call per time, the call cumulative that includes, so this is for all the different calls to that function, and the total time, which includes the call of the sub-functions as well. I think that's how it works. No, that's the cumulative time that includes the call for the sub-functions as well, right? So timing lists.py was called once, but took 35 seconds to execute because it executed all the others as well. But in itself, it took only 30,000th of a second because immediately it was delegating to those 3 functions, and those took a lot of time with add taking most of the time. You can see that range was also called to create the ranges and things like that. So you really see the internals of the program. So if you had this kind of output to profiling your program, you would know that there is very little point in improving with append and with comprehension but you would look very carefully at with add, because any gain you make there will be substantial on your overall program. And sometimes here it's simple because I'm calling each of those functions the same number of times, but sometimes it's a trade-off where some function that's called very often is very fast, and some function that's called less often is quite slow, but maybe when you multiply the two together, both have very different contributions to the final time taken, and it could go either way. So I told you there were two ways of profiling. This was the first one from the command line, and this is the second one from the module itself. So for this, I need to define internally a function, and this function will be called test. And I don't need to, I can import the cprofile module instead of the profile module. That one might not be installed quite everywhere, but then I just do cprofile.run and then the function I want to run. And this will do as I hope it does. So let's just run it, and this time we don't need the cprofile argument. So there we go, we have it, and it's a very similar picture to the previous one, of course, it should be. But you can see that there is two ways to basically call profiling.